quite frequently, when it comes to expanding a single bracket with a term in front of it, we'll quite often not have just purely a term with a bracket. There will be extra terms thrown in there, or even other terms with other brackets, and it's our job to make sure that when we expand them, and we expand any other parts to it, we have to be able to simplify things. Remember, when it comes to algebra, we want to take an expression or an equation at the start and simplify it to a point where it makes it as easy for us to work with and as smooth for us to work with as is humanly possible. And that's exactly what we're going to look at here. Now, what I mean is when we've got things like this. So you'll notice that each of these has terms with a bracket, and the brackets have coefficients outside, sometimes a mix of constants, variables, etc. But there's also extra parts. Now, this extra part might be a number added or subtracted at the end. It might be a number in front of the bracket where it's adding or subtracting the bracket itself. It might even be a combination of a second bracket too. It's our job to be able to expand them and simplify the entire thing together so that we can work with it. Well, the question then is, how do we do that? So let's investigate. Let's look at the first two examples that were there from that slide. So 2x bracket x plus 1 take away 3. Now, we've discussed many ways in which we can expand brackets, singular brackets on their own. We've looked at two variations of it, which are including crab claw and a table methodology. Now, when we get a question like this with algebra, if you think to BODMAS, the first thing we want to get rid of when it comes to BODMAS is the bracket. Similarly, with expressions like this, the first thing we want to get rid of is the bracket. So anytime you've got brackets, such as this here, your first focus has to be getting rid of it. Now remember, when it comes to this, we've got a variety of different methodologies we can use in order to expand the bracket. I could, for example, use the crab claw technique. So I'll have 2x bracket x plus 1, and then expand it using that. So I'll do 2x times x plus 2x times 1. So I get 2x squared plus 2x. Or I could use the table methodology. So there's my multiplication for the table. I'd have an x and a plus 1 along the top, and I'd have 2x there. So I'd then fill in my table with 2x squared plus 2x and get the exact same answer I got with crab claw. The bottom line is I'm going to get that answer no matter what, and I'm going to then substitute that back into the expression in place of the 2x bracket x plus 1. So I'll have 2x squared plus 2x, and then I've got this extra takeaway 3 here, and that comes through at the end. Now, something like this is relatively straightforward to expand. We just have to remember to simplify once the bracket's gone, gather any terms together. If that was just a 2 rather than a 2x, I'd end up with 2x plus 2 and then take away 3. So I'd have to simplify the plus 2 minus 3. That's second nature to us at this point. However, one like this, the second one here, you'll notice that the bracket is the second part of it. Now, quite frequently, the mistake you see here is somebody will look at that and say, right, if I work from left to right, I have to do 4 take away 7, and what they'll end up doing is writing it as negative 3 bracket 2 plus y. Well, I'm going to tell you now, that is completely wrong. Don't ever do that. That is the wrong way to do it. The bracket has to be done itself, and we have to get rid of that. Now, a key thing to remember is when we're doing it, this is a negative here at the 7. We have to make sure we bear the signs in mind. So if I was doing crab claw, I'd do the crab claw technique using the negative 7 here and taking that into the bracket. And then whatever signs I get out, I can replace them with it. So I'd end up doing negative 7 into the bracket, so I get negative 7 times 2 plus negative 7 times y. So I get negative 14 take away 7y. My expression would then have to be written as 4 take away 14 take away 7y. And if we simplify the 4 take away 14, it'd be minus 10 take away 7y. If I use the table to expand it, again, I could do the exact same thing, and I'd do the exact same thing we always do with the table. Take in the plus y's, there's my multiplication, and outside it I'd have the negative 7. I've got to remember that the entire part out there goes with it. So if I do that, I'd get the negative 14 minus 7y again. So I get the exact same thing as what I got here, and I'd do the exact same method. One like that, it is vital that we make sure the signs are correct. That's a key thing, and it's a key area for error that comes up quite a lot. So be wary of that. These two examples here, the first one, I've got two sets of brackets. So I've got two things that I need to expand and I need to then simplify and get rid of. Well, to do it, we do each bracket individually and then combine everything together. And it's the same with the second one. There's just a slight wee tweak that we have to look at, and we'll look at that in just a second. So if I take this first bracket and I expand it, I'm going to do 2 times the y plus 2 times the 1. The second bracket doesn't get touched by the 2. You have to remember that 2 is only touching that first bracket. As soon as you close the first bracket off, the effect of the 2 is muted for the rest of the expression. You have to see what touches it. Well, the next thing it touches is the 3 into this bracket. Now we've got to watch the signs when we do this and remember what we do. So in this case, I'd have a plus 3, that would be times the 2y. I'd then keep my plus 3 because that's what we're taking in, and this time it would be multiplied by a negative 3 here. So in this case, my whole thing would then become 2y plus 2 plus 6y take away 9, which I could simplify, and I'd get 8y take away 7 overall for the entire thing. So I'd be able to get that from it. This would be fine and similarly done if we used a table. So we could do the first bracket, the 2 times the y plus 1, and we get 2y plus 2, exactly as we got there. I'd then do my second one, and I'd remember when I did it, I'd take the minus in with the 3, there's my times again, and I'd take the sign with the 3 that's outside the bracket, so it'd be plus 3. I'd then have plus 6y plus 3 times negative 3 gives me minus 9, and would you look at that, there is the first part of the expansion, there is the second part, and the signs have dealt with themselves. So be very careful which of the two methods you work with. You just have to make sure your signs deal with themselves and you get them correct. And if we look at this second one, similar idea. Using crab claw to expand it, that 3 is only touching that first bracket. We only work with this there, which is fine. So we then say fine, that means 3 times 2z plus 3 times 5. Now you've got to look at this second bracket. There's nothing outside that bracket besides a negative. Well, if you have a bracket written on its own, remember there is something there. It's technically hidden, and it is a 1. So in this case, that bracket is actually getting multiplied and expanded by multiplying everything inside it by negative 1. So I then have negative 1 times y, take away 1 times the negative 3. There's a little trick for you. If the bracket's shut off like that, you have to imagine there's a 1 hidden outside, or in this case, a negative 1 because I'm subtracting. If I then do this and I simplify everything, I'd have 6z plus 15 minus y plus 3. And I simplify everything together. Now the one thing you need to make sure you watch is the z's and the y are different. When we simplify it, we don't combine things that are different, remember. They have to stay on their own. So the 6z, the minus y, stay on their own. So I'd have 6z take away y and then plus 18. Or I could have negative y plus 6z if we're going to stick with alphabeticals. I personally don't like starting with negatives, which is why I've written it in that manner. Again, if we were using the table method, this would all still work out the same. We just have to make sure we got our signs and everything right. So the first bracket would be given by this, and we'd end up with the 6x plus 15, which matches this first part here. And the second bracket, as I've said, we take whatever was in the bracket here, the y and the takeaway 3. This time though, my multiplier going along the way would be negative 1. So I'd have minus y plus 3, and again that matches up with the second part there. So you get the same bits matching up no matter which method you choose and which method you use. You just have to be very, very careful of the signs when it comes to these sorts of things. So I'm going to put up a couple of examples, pause and have a go, see what you get at the end. So you'll have had time to have a crack at these. I'm going to fire through these. I'm going to use the crab claw technique on all of them, but remember, either method doesn't matter. Just watch the signs. So expanding this first one, I'm going to take the 5 in, and I'm going to do 5 times 2y, take away 5 times 3, plus 7y. So what I'll end up getting is I'll have a 10y minus a 15 plus a 7y, which we simplify to give you 17y, take away 15. Remember, if you use the table, focus on the bracket in the table, and then make sure you sort your plus 7y at the end. This one here, again, I'm going to do my crab claw into the bracket, but you've got to remember, it's minus 2 that goes in the bracket. So my 3x stays the same. I'll then have minus 2 times the 5x. That plus stays the same. And then I'll have minus 2 times the 4. Remember, the line for the net minus 2 times 4 doesn't touch the plus, so the plus stays there. So I'll then have 3x, and I'll have minus 10x. This will then become minus 2 times 4 gives me negative 8, plus minus 8 plus minus becomes a minus. And then we simplify it and we get negative 7x minus 8 is our final solution for that one. This one down here, remember we expand each bracket on its own by taking the elements in. So I'm going to take in the 2 for the first bracket. Now remember, it doesn't touch the second, so the negative 3 is what's going to go in the second bracket. So if I do them individually, my first bracket becomes 2 times 3z plus 2 times 4. I've then got negative 3 going into the second bracket, so it's going to be minus 3 times 4z. Takeaway comes to the middle of the bracket. Remember, nothing's touching it, so it stays the same. And then it would be negative 3 times the 3 that's there. Now, it's simplify each part and gather the bits that are the same together. So this would be 6z plus 8 minus 12z plus 9. So I'd end up getting minus 6z plus 17. If I wrote it as 17 minus 6z, if I didn't like starting with a negative, I'd be perfectly fine as well. They both mean the exact same thing. Either variation's fine on that. But that's what we'd get ultimately. This last one here, same idea. The only difference, the first bracket has an x outside it as part of the expansion. It doesn't change what we do. We still multiply into the brackets, and the 2 does the second one. The 3x doesn't touch the second one at all. So we get 3x times x squared plus 3x times 5x. Then we get into our second expansion. It's then plus 2 times the x plus 2 times the 1. So 3x times x squared, that'll give me 3x cubed. I'm then going to do 3x times 5x, gives me 15x squared. And then I'm going to have plus a 2x, and then plus a 2 from the other calculations. Now I can't gather anything near the same together. Remember, x cubed, x squared, and x are all different. So that's my final answer. I'm left with just a cubic there. So it's the same set of steps every single time. We look at expanding the bracket first, then we simplify, and we have to make sure we're doing our simplification correctly. So what are the rules for this? Well, the rules are fairly straightforward. Firstly, we have to expand each bracket on its own. The bracket is only affected by the coefficient that is outside, whether this is just a variable, a letter, a number, or combination thereof. Now, unless the coefficient of the bracket touches it, you can't do anything for it. We had a few examples of that a moment ago. Be very careful of the signs involved, and I illustrated and showed you how we can either A, deal with it, or B, spot what's going to happen. And then the final part is we always simplify the full expression afterwards by gathering the same terms together. Be careful what you gather together. That last one demonstrated that things such as x squareds, x cubes, and x's, whilst the same base letter might be there, they're not the same, so they can't be gathered together. Be very, very careful of that one. Remember all these rules and the examples, and you'll be fine. Just remember, think smart, solve fast.